All right, how's everybody doing today? Good, good, good. Okay, we're almost done with the first week back, so that's always the roughest after a big vacation. But we have our next focus activity today. We'll go ahead and wrap up our current lesson over systems of equations and quadratics. I think we have a little bit more to do with quadratics. Then after that, I've got the exit ticket I spoke to you yesterday about, and that should pretty much take care of today. Remember, the assignment, the homework, is due tomorrow. We can talk about that at the beginning, and then we'll have our quiz, and hopefully we'll be able to start the next topic, currency conversion. What was the homework, by the way? There you go. So this packet was a combination of both notes and assignment. So I specifically chose certain problems I wanted to work together. All the problems that we don't work together, that's the assignment. So here we have our focus activity. It says, number one, the students in a school are all vaccinated against measles. 48% of the students are males, of whom 16% have an allergic reaction to the vaccine. 35% of the girls also have an allergic reaction. A student is randomly chosen from the school. Find the probability that the student, and we have our two questions here. So I'd like to give you the opportunity to look at the problem just like we did the probability problem for the first focus activity. So sometime between now and tomorrow, right when we go ahead and meet, I'd like you to go ahead and try to solve this problem. Okay, find the 2% for me. Okay, one of them you can go ahead and probably round to the nearest percent. I went ahead and rounded mine to the nearest tenth. But if you're having trouble getting started, I would recommend, what is it that I just drew? I'd recommend a tree diagram. That's a really good way to see all the scenarios and sort through your data, the information that you have. Okay, so if you want to swing by in the morning, check your answer with me, okay, more than welcome to do that. Okay, so we'll put that to the side, and hopefully in a little bit we'll take a look at it. The only other thing I need to mention about tomorrow, remember what is happening during third period. Okay, you do have a fire drill. Now, the most recent email that Mr. Anderson sent out alluded to a fire drill, but it didn't have anything about the hazmat drill, even though the document for the year says there's going to be a hazmat drill as well. So I'm still counting on there being one. You really don't even notice it if there is one. That's when, there's some kind of danger off campus, so the campus is still locked. But inside the school, it's business as usual. Okay, very similar to a lockout. Just think about your third period class, where you would exit the building, on what side of the building you're going to go. If we were in here, we would go where? East or west side? We go to the east side where the band would normally practice after school, right down the stairs past the nurse's office to the sidewalk and then to that parking lot. Hello. Okay. That's going to be happening during third period tomorrow. All right, so any questions about what's happening in the next couple of days or anything next week? Okay, well, let's see. We got to talking about some quadratics yesterday, and specifically where you're looking at some of the different factoring strategies that we had. And I introduced you to a strategy that I like. What's the sentence that tells you the steps? Okay, my father drives a red Mercedes convertible. Okay, again, if you have a strategy that works for factoring trinomials, please continue to use it. If you like the method, fantastic. But I did end the class yesterday by saying, okay, let's go ahead and find the values of x that makes this true by factoring. All right, so somebody walk me through this process. Like, what's that first M stand for? Multiply. Okay, so what would I multiply? Okay, so the first coefficient times what? So 15 times 2. Okay, so the first coefficient times the constant, 15 times 2 will give me 30. Okay. Now, what's the F in father stand for? Factor. So this product that I got by multiplying the leading coefficient and the constant, I need two factors, two numbers that will multiply to give me 30, but they also have to add to give me negative 11. So besides their values, what do we know about these two numbers? They would also have to be what? They would have to be negative. I've got to multiply two numbers to get a positive, but the sum has to be negative. So that would tell me they both have to be negative. Okay, it's got to be what? 6 and 5. All right. That right there is the key step. If you find the two factors, okay, that fit those conditions, the rest of the problem is going to go very quickly. Okay, so I multiplied. I factored the d in drives. Divide. Okay, Stephanie, what am I going to divide by? Okay, so that leading coefficient right there. So I'm going to divide by 15. 15, okay. Lucas, what does the R stand for?
What are you talking about? I'm sorry.
Oh, that's fine. We were doing the please excuse, or went off on the wrong one. My father drives a red Mercedes convertible.
Oh, red. Or,
yes, that's right.
Yeah,
That's right.
But,
another word for simplify.
Rash? Or reciprocate?
Ooh.
Or reduce.
Reduce. There we go. All right. So we're going to reduce. Yes. So let's see. What is a negative 6/15? Okay. Okay, negative 2/5. All right. And what do I get for a negative 5/15? Negative 1/3. So remember, these here, this is the one thing you need to be aware of. When you're simplifying these, sometimes your factors will divide evenly. Remember, you want to keep it as a fractional value because the numerators and denominators are actually very useful to me. So this is where I'm going to move these numbers now, and I'm going to get the two binomial expressions that I have. Now, we also want to solve the equation. So this is still going to equal 0, as the original equation did. So what would negative 2/5 look like here? Would it be negative 2x plus 5? 5x minus 2. 5x minus 2. We always start in the denominator. So 5x minus 2 times, what would negative 1/3 give me? 3x minus 1. And there we go. And then, of course, does anybody want me to check that real fast? Multiply through to show that we will get the trinomial? Okay, so how am I going to find the solutions to the equation, though? How does this help me? Yeah, we solved for x. You guys remember what we called it yesterday? It started with a z. The zero product property, yes. Okay, so I said that if you multiply two terms and the result is 0, one or both of the terms have to be 0. So we're going to take each of these and just set them individually equal to 0. And then we're going to go ahead and solve. So let's see. I would add 2 and divide by 5. So first off, x equals what? 2/5. Okay. That's one solution. And 3x minus 1 is equal to 0. So add the 1, divide by 3. X equals 1/3. So there we go. Now, these actually are very important to the quadratic, the parabola, and we'll be looking at this in a lot more detail. But if you set the quadratic equal to 0 and solve, this tells you exactly where the parabola touches what? The x-axis. These are the roots, your zeros, your solutions. Okay. And in fact, since this is a more of a review than anything, we may not have the opportunity to bring it up again, just depending on if anybody has questions. Does anybody notice anything about the answers we got and the strategy we used? Okay. If all you're trying to do is look for the roots, then you can actually stop when you get to the simplified fractions. Just take the opposites of those, and those will be your roots. Okay, but if you don't remember that, you can just set the zero product property and continue to the answer. How many people had the opportunity to go home yesterday or even this morning maybe? Go ahead and get those two answers. All right. Okay, any questions on that? All right. Okay. Well, let's move on to our last section here. Solve the quadratic equation by GDC, and this kind of walks you through a whole process. I'm just going to go ahead and get right to the point, show you how to do this on the calculator. So A is the first one I want to take a look at. X squared minus x minus 4 equals 0. Okay, so what I'm going to do is come on over to my calculator here. Okay, so I'm gonna come over here. Now mine's on my scratch pad, so if you're at your home screen, choose graph or however you want to go ahead and get to this particular screen. If you want to go ahead and use another method, let's see, what's the problem here? It is x squared minus x. So I'm just going to go ahead and type it in. So x squared minus x, and then we have minus 4. Okay. So again, I'm setting it equal to 0, so I'm trying to find the values of x that make it true, but those are also its roots. So when I push enter, I'm looking specifically for where the parabola crosses the x-axis. And here I have 2 solutions. Now, when you're dealing with parabolas, there's actually 3 different cases. Typically, you're going to have 2 solutions. It's possible to have only 1 solution, and it's possible to have no solutions. But can anybody tell me what's going to happen if there's no solutions? Those answers actually turn out to be what? Starts with an I. Imaginary. Do you guys remember imaginary numbers? Okay. All right. So we can look at those if you would like. So there's a variety of ways to go ahead and find these values right here. Here's probably one of the fastest ways. If I want to know this value, I mean, a lot of people use trace. What I like to do is if you go to menu, let's analyze the graph. I'm looking for the 0. Remember, that's the x-intercept. Those are the roots. Now, we saw this the other day. It says lower bound. What does that mean? There you go. I want to put this vertical line to the left of the value I want. So I'm looking for this guy right here. Okay, this value. So I'm going to go ahead and place it just to the left. When I push enter, it's going to lock it in place, and it now says what? Upper bound. Okay, so I'm going to sweep it across, and there we go. The first answer I should get is 2.56. That's one of my roots. Okay, now if I want to go ahead and find the other one, I'm going to do the exact same thing. So menu, analyze graph, 0. Okay, so I want this one now, so I'm going to move it just to the left. And you can even move it pretty far to the left of your target if you really want to. You don't have to. But I'm going to go ahead and enter it right there. Now, as soon as it hits it, it's going to pop up that value. So this other one is a negative 1.56. Okay. So those are my 2 solutions. That's the technology method. 2.56 and negative 1.56. There we go. Did anybody want me to solve this by hand to show you that we're going to get the same thing? We're good? Nobody's interested in seeing quadratic formula or completing the square? Okay. Well, let's try another one here. X squared minus 3x plus 7 equals 0. Okay. So let's see. I'm coming over to my calculator. I'm going to go ahead and clear out this previous one, document B. All right. Go back over here. What was it? X squared minus 3x. And then we got a plus 7. Okay. So I'm going to go ahead and click enter. Now, I brought this up just a minute ago. This parabola is not crossing the x-axis. Okay. So what do you think I'm going to put as my solution? There is no solution. Okay. Now, I have never seen imaginary numbers appear on either of the paper exams. Would you like me to solve this and show you what the imaginary answers would be? Who said no? Okay, Jacob. But would anybody say yes? Okay, Kate. All right. Because we're curious, right? You know. Exactly. Okay. All right. So here we would say technically there's no real solutions, but let's go ahead and run through this. Let's see why there's no real solutions. Of the 2 methods, I would probably say let's go ahead and use Pythagorean theorem. Okay, x squared minus 3x plus 7 is equal to 0. Remember, this is your A, this is your B, and C. So A and B are coefficients of those terms. The quadratic, the linear, C is your constant. In fact, it also is your y-intercept. But quadratic formula, just like factoring, you want to have all the terms on one side. You want to set it equal to 0. Can anybody remember what is the quadratic formula? X equals what? Negative B. There we go. If anybody was doing it, I didn't hear it. I was hoping that I would hear the opposite of B plus or minus the square. You know, did any of your teachers ever Show you that by singing it? Not that song? What'd they use? Who wants to sing it for me? You had what? I don't know what that is. Oh! I was like, Ubis. Is that teacher here? Oh, okay. So what did Ubis do? Okay. Something you can tap your foot to. But a good YouTube video. Okay, there we go. All right, just a little FYI. Does anybody remember what b squared minus 4ac was called? Starts with a D. That is known as your discriminant, yes. The value of the discriminant could actually tell you before you started how many solutions, or if no solutions existed, you were going to have. Okay, so let's go ahead and plug all this in. So b is -3, so the opposite would be +3. Plus or minus the square root. B squared would be what? 9. Minus 4 times A is 1 times C, 7. And this is all divided by 2A, which is 2. 2 times 1. Okay, so let's simplify the inside here. Looks like I'm going to have 9 minus 28. So that's going to give me negative what? And there you go. That's exactly why it's not crossing the x-axis. This is not... Now, I say that technically we actually can't take the square root of a negative value, but we do use that concept for a variety of things. We kind of found a way to get around it. In fact, if I were to simplify this to completion, I would go ahead and say 3 plus or minus I square root of 19 over 2. Okay. Remember, by definition, I equals what? The square root of -1. There you go. Okay. Does that kind of also bring back some memories of algebra? Okay. Anybody like me to continue elaborating on this, or are we good? I mean, even if you don't, I still think you're great pupils. You get that one? I, pupil? Come on. Okay, so sometimes that joke wasn't as corny as my other ones, but... Really, John Henry? You know, sometimes, John Henry, Iris, I wish I could make you laugh. Iris, Iris, I could make you laugh. Get it? You know what? Okay. Okay. Okay, would you at least say that problem was pretty easy? You guys have it? I'll stop now. Okay, come on. Right. Hey, as long as John Henry leaves happy, I'm good to go. Okay. All right, so C turned out to have no real solutions, but we found the imaginary. F, our last problem on the notes, and then I have another problem I want to go ahead and work with you very quickly. So F says x squared plus 9 equals 8x. Okay, so if I'm going to go ahead and do this via the calculator, all right, I'm going to have everything on the same side. So x squared plus 9 minus 8x, and then you can put it in standard form. You know, that really doesn't make a difference. You could solve it graphically as is. Just, again, another kind of FYI moment. If you were to go ahead and plug in x squared plus 9, and then you graphed the linear function 8x, graphically, you'd look for what? The intersection of the two graphs. Okay, so really, I mean, solving equations, that's exactly what you're doing by hand. But let's take a look at this last one right here. X squared, and I'm going to go ahead and put it in standard form, x squared minus 8x plus 9. Copy B. All right, so it was x squared minus 8x plus 9. Okay. So this one's a nice graph. I can see the two intersection points right here, the two zeros. How did I get there again? Menu. Okay, analyze. We do want the 0. Okay, so let's say I want this one right here. I'm just going to put it to the left, that where it is lower bound. Enter. Upper bound is to the right. And there we go. So that first value should be 6.65. Okay. This second one right here, menu, same steps, analyze graph, 0. Lower bound is left. Enter. Upper bound is right. So those are my two values that would make it true, 1.35 and 6.65. Okay. Questions? Yes. Say again, sir? Oh, are you talking about like numerical solve or something like that? There you go. So algebra, menu, algebra, polynomial tools, find the roots. Okay, so the degree is 2. And yeah, all you need to do is go ahead and plug in your two coefficients and your constant. So this one was what, 1, what was it, -8? And then +9? There you go. So okay, it'll go ahead and write out the function for you. And there you go. And it actually gives you more decimal places. Good. Yeah, the thing about the Inspire, there's going to be a lot of different ways to do it. I'm just showing you the one. But that works as well. Okay. Questions? All right, here is our last problem for today. Now, it's not in your notes, but I thought it would be good to go ahead and have a problem, maybe some kind of application problem to actually use what we know about quadratics. This one says a rectangular swimming pool is 12 meters long by 6 meters wide. It's surrounded by a pavement of uniform width, the area of the pavement being 7/8 the area of the pool. So if the pavement is x meters wide, show that the area of the pavement is 4x squared plus 36x meters squared. And then here's the thing, B and C seem like the same statements to me. Hence, show that 4x squared plus 36x minus 63 equals 0. Well, it just wants you to find the values of x that make that true, and then you're just presenting them in C. So I'm kind of not exactly sure why they said it that way, but oh well. Okay, so if you want to write this down, or if you wanted to take a picture of it maybe with your phone for future reference, okay, or if you just wanted to follow along, okay, however you want to go ahead and do it. Now, for a problem like this, I would recommend starting with a diagram. If you see a picture, it's usually easier for people to go ahead and kind of see what's going on, sort through the information. So, let me get a square here. There we go. Okay, so we've got this diagram right here where the inner square, or if you're using rectangles, whatever, is going to represent the pool, and then we have the sidewalk around it. What does it mean that it has a uniform width? So it's the same width all the way around. So if we're saying that the width of it is x meters, so that's x meters as well as that right there. Okay. Now, do we know the dimensions of the pool? Yeah, 12 by 6. Okay, so this is not going to be to scale, and that's fine. So this is 12 meters by 6 meters. Okay. So what's the area of the pool? 72. So we have 72 meters squared. All right, so part A, it says if the pavement is x meters wide, okay, which I just showed you here, show that the area of the pavement is 4x squared plus 36x. Okay, now this could potentially be very similar to a problem that you do get on one of your paper exams. I have seen where they'll set up a scenario like this, and they actually want you to show steps like deriving a specific expression that they might give you. Okay, so would you like to take a minute to try this one on your own, or you just want to continue to walk through it together? Take a minute? Okay, let's see if you guys can get to this right here. 4x squared plus 36x. How would we go ahead and show that the area of the sidewalk, the pavement, is that expression, square meters. $149. Okay, so you probably have not had a whole lot of time, definitely not to finish the problem, but hopefully maybe to kind of start deriving that particular equation, or maybe you're on the right track. Just because of the time, I'm going to go ahead and kind of run through it. I'm going to ask some leading questions here. We already know from the diagram that one side length of the pool is 6, right? So in order to answer question A, I want to know the dimensions of the outer edge of the sidewalk. So would everybody agree this is 6 as well? Well, what are these two little segments at the end of it? Remember, this one is X, and this one is X as well, because it's a uniform width all the way around. So what would the outer edge for that length of the sidewalk be? Think about it, we have X plus 6 plus X. There you go. So this length of the outer edge would be 6 plus 2X, or 2X plus 6, however you wanted to write it. So now I'm going to follow the same reasoning to go ahead and get the height here. Can you tell me what that would be?
12 plus.
There you go, 12 plus 2x. And how do we find the area? Yeah, I'm going to multiply the two together. So I'm going to take the 12 plus 2x meters, and I'm going to multiply it by the 6 plus 2x meters. Okay. Now let's see here. 12 times 6, we already knew that was 72, plus 12 times 2x, 24x, inside 2x times 6, 12x, last, okay, plus 4x squared, okay. And I just kind of went through the letters. Remember, that was FOIL. That's our acronym for multiplying these binomial expressions. So it looks like I am going to end up with 4x squared plus how many x's? 36x, and then plus 72. Now this represents the area of the entire figure. A wants the area of what? Just the pavement. So how does this change? Subtract 72, remember that was the area of the pool. So when those cancel, see, there's the expression that gives me the area of just the sidewalk. Okay. So that idea, a concept like that, could very easily show up on the paper exam. I want to say, in fact, last year, one of the problems on paper 1 was just like that. Okay. So now B says, show that 4x squared plus 36x minus 63 is equal to 0. Well, we're trying to figure out the value of x, right? Where did that 63 come from? What's one bit of information in the problem that we haven't used yet? There you go. We're told that the area of the pavement is 7/8 the area of the pool. So I'm going to take 7/8 of that 72, and that's where I get the 63. Okay. So if I know this expression represents the area of the sidewalk, but I know the area of the sidewalk is the 63 meters squared, then I'm going to equate them. I'm going to say 4x squared plus 36x equals 63. So all I did to get B was just subtract that 63 over. 4x squared plus 36x minus 63 equals 0. Okay. Is everybody okay with how I set that up? And see, now it's a problem just like what we were doing. I mean, you can solve it however you like. Technology is probably going to be the fastest way. Just to go ahead and save time here, because I want to go ahead and get to that exit ticket. If you were to go ahead and solve for x, as I previously showed you, you're going to get two values. You're going to go ahead and get 1.5, and you're going to get negative 10.5. Okay. Can I accept both answers? No, which one do I have to throw out? Yeah, the negative, because that's not a reasonable answer. We can't say it's negative 10.5 meters wide. Okay, so the uniform width of the sidewalk should be 1.5 meters. And you can double check that if you want to use quadratic formula or, like I said, the calculator. Okay. But is everybody okay with how I worked through the problem? That's the main part. Any questions? Okay, then let me go ahead and pass out your exit ticket. I got 55, so we got about 13, 14 minutes. You still got plenty of time. There's only two problems on here. One was a system, and the other was a quadratic. Here we go. Here we go. Now, we are going to work this independently. I'll go ahead and let you use your notes, and you can definitely use the calculator. Yes, sir. Two, three, one, two. There we go. All right.